Hi, we're looking at something called the quadratic formula, and I'm going to show you where it came from. And what I'm going to do is I'm going to write the general form right here. Ax squared plus bx plus c equals y. And over here, on this side over here, I'm going to have an example, and I'm going to have 2x squared plus 4x minus 9 equals y. Alright, so we're going to take a look at solving, and we've solved this by completing the square, and the first thing we did was we took 2x squared plus 4x plus 9 equal to 0, and then we go ahead and we move c to the other side, and I would do that in this case by adding 9. So I end up with this as my equation. Alright, so I'm going to do the same thing here. I'm going to have ax squared plus bx plus c is equal to 0. And I'm going to move c over to the other side by subtracting c. And okay, so over here I have a negative c. Alright, so the next thing I'm going to do is when I complete the square, I want this to be this a to be 1. It's 2 right now, so I'm going to divide everything by 2. And I'm going to get x squared plus 2x is equal to 9 halves. And over here I'm going to divide everything by a. And I'm going to have x squared plus b over ax is equal to a negative c over a. Well, what I need to do now is take this b, which is 2, take half of it, and square it. So in this case, I'm going to get 1. So I'm going to write x squared plus 2x plus 1, and since I wrote 1 on the left side, I have to add 1 on the right side. Okay, and over here I'm going to do the same thing. I'm going to I'm going to turn down the volume on my cell phone. I'm sorry about that. And what I'm going to do is I'm going to take half of b over 2a. Now, to take half of b over 2a, I'm going to, since it's a fraction, I'm going to multiply it by 1/2, and I get b over 2a. And I'm going to square that, and when I square that, that's b over 2a times b over 2a, and I get b squared over 4a squared. So over here I'm going to have x squared plus b over a x plus, to complete this square, it's going to be b squared over 4a squared. Well, I'm going to do that here. I'm going to have a negative c over a, and on this side I'm going to add b squared over 4a squared. Alright, now I'm back to this one, and what I'm going to do here is get a common denominator. 1 is the same as 2 halves. And so I'm going to get 11 halves. And since this is a trinomial square, it can be written as a binomial square. And so it can be written as a binomial, taking the second power, and it's the square root of this one, or half of this b, and so it's going to be x plus 1. So I've rewritten this in this particular form. Okay, I'm going to make one little adjustment here, see if I can. I'm going to write my 1 a little bit better. I don't know if that was much better. Okay, over here I'm going to get a common denominator also, and it's 4a squared, so I need to multiply this negative c by 4a on the top, and I'm going to have 4a squared on the bottom. And then I'm going to be able to put these together, and I'm going to write the b squared first minus 4 times a times c all over 4a squared. And if you notice, this negative symbol is now this minus sign here. Over here again, this is a trinomial square. And what I'm going to do is I'm going to write that as a binomial. And it's going to be half the middle term, or the square root of the last term, and so it's going to be x plus b over 2a. Alright, so what I'm going to do is take the square root of this side. I'm going to have x plus 1 is equal to plus or minus the square root of 11 halves. And over here I'm going to write x plus b over 2a is going to equal plus or minus the square root of b squared minus 4ac all over 4a squared. Now, this is the same as plus or minus the square root of b squared minus 4ac all over the square root of 4a squared. And I know the square root of 4, it is 2, and the square root of a squared is a. So now I have x plus b over 2a equals plus or minus the square root of b squared minus 4ac, all of that over 2a. Now if you notice, my denominators are the same on both of these. That's really nice. So over here I'm going to subtract the 1. And I'm going to get x equals a negative 1 plus or minus the square root of 11 over 2. Now I have not rationalized the denominator. And over here I don't have to worry about rationalizing the denominator. And if I subtract b over 2a from both sides, I get a negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. And so the complete form is x equals, and then in my numerator is a negative b plus or minus the square root of b squared minus 4ac, all of that over 2a. And this is what we call the quadratic formula. And it's a formula that gives us the x-intercepts for any quadratic equation. So let me just show you a couple of things yet. Again, x equals negative b. Originally I had this over 2a plus or minus the square root of b squared minus 4ac all over 2a. This right here is the equation for the line of symmetry, or the x value of the vertex. So if I have something like this, and I have a parabola that dips down right here, okay, and right here is my line of symmetry. This right here is x equals a negative b, or the opposite of b, over 2a. This distance right here is going to be a negative b over 2a plus. This distance right here is, I'm adding this amount, the square root of b squared minus 4ac over 2a. This part right here is this amount. Likewise, this amount is a negative square root of b squared minus 4ac over 2a, because I'm subtracting that amount from the line of symmetry. So let's just go one step further, and let's say I have a situation where I have one solution because my vertex hits the x-axis. Well, right here is my line of symmetry. And so I can't go the left and I can't go the right. So in this case, that distance, that plus or minus the square root of b squared minus 4ac all over 2a, that has to be equal to 0 when that happens, because my vertex is on there. That's just a little side note that we're going to use probably in our third video.